The first thing that I would want to know from the kids is what maths can you actually explain, and what meta language do you have to explain that maths? Because a lot of kids can perform on paper, but then when you actually ask them to explain not just how they did it, but explain the maths behind how they did it, and then keep asking the question, but why? But why? So there's something called the 3 whys. So you keep asking why 3 times, because then you see if they can go deeper and deeper in their explanation of why they did it that way, why that works, and then even going into how else could you have done it. Sometimes they're really good at maths because they're very good at, we're going to tell you how to do something and then you're going to go and do it. When they're told to do something and how to do it, they're very compliant and will go and do it. And that doesn't mean they necessarily have deep understanding. It just means that if you show them a procedure, or you show them how to solve something, they can then go and solve things that look the same, following that same procedure. In year 5 and 6 is about explaining and justifying. So if you've got kids who can only do, and they can do whatever you ask them to do, but they can't explain and they can't justify, then they're not at year 5 and 6 level. Because that's the difference between the lower grades and the higher grades, is that explaining and justifying. How do you know it's right? And then they have to be able to actually justify how they got that answer, how they know that's right. Talking to someone else who may have done it in a different way, and then deciding, okay, which way do I think is more efficient? What I say to the kids is, if you just want to pass a test, this will still help you to pass a test, because you're going to have such deep understanding that it doesn't matter what question they throw at you, you're going to pass the test because you're going to have deep understanding. With all year 5 and 6 kids, we want to make sure that they've got deep relational understanding, not just doing maths. There's no new multiplication and division, and there's no new addition and subtraction, because those 4 operations they're supposed to already have all their understandings about. So in year 5 and 6, they're now applying what they know about addition and subtraction and what they know about multiplication and division to bring those concepts together and to apply them to different areas of maths. For year 5 and 6, can make a decision how they teach addition and subtraction, use algorithms and compensation. Once they've got the algorithm to 2 digits, they've got to do compensation. And then once they've got the algorithm to 3 digits, they've got to do compensation. So there's no more multiplication and division, but we're using what we know about multiplication and division to investigate highest common factor. And one of the reasons that we're doing that is because we want to look at equivalent division calculations by dividing by the same factor or multiplying by the same factor. And to do that, we need to understand divisibility tests. So not just teach the kids the divisibility test and say this is how you know if a number's divisible by, say, 3. It's more about why is that the test for divisibility by 3. And then at the same time, up until year 5, the children haven't been dividing remainders to create fractions. They've just been having remainders in division. So now we're not just going to say put the remainder over what you divided by. We're going to actually let them investigate dividing remainders to create fractions. So you can see even just this little part that I've just described there, that's a lot deeper understanding than just, okay, let's use an algorithm to divide. Okay, let's just put the remainder over the number that we're dividing by. It goes much, much more deeply, but it also goes relationally. They might know tables and they might be able to use tables to divide, but that's not going to help them to be multiplying by 2-digit and higher numbers and also dividing to create fractions. And then when they start to multiply and divide decimals by whole numbers, the only way that they'll be able to do it, if all they know is tables and then the answers to division, is they'll have to have an algorithm. but the algorithm is not mandatory. And in fact, especially for kids who are really thinking mathematically, they never ever need an algorithm. If they wanted the exact answer, they could use a calculator or their phone. But this is making sure that they already have reasoning to know I was expecting an answer about that big. Even if they're dividing a decimal by a whole number, they were still expecting an answer of that size. So when I do multiplication and division in year 3 and 4, it's not just teaching tables, it's really explicitly letting the kids investigate the distributive property and how the distributive property relates to both multiplication and division. Because when we, for example, divide by 2, the kids are finding a half. When they find a half in year 5 and 6, they find out that I was actually multiplying by a half. So that's why the distributive property works in multiplication and division, because in year 6 is that division is multiplication by a fraction. And then when they start multiplying by fractions in primary school and then dividing by fractions in high school, that's why you can invert and multiply, because it's the inverse relationship. This starts down here. This is year 3 and 4 level. And then we get up here. The area model is where we start looking at it with 2-digit numbers. And then you can see down here, we're starting to multiply and divide decimals by whole numbers. And here you've got 2 or 3 different models for that without having to resort to an algorithm. This is my model of the distributive property. So I actually show how we're distributing the multiplication over addition. And then with division, you can see that at the same time as we're dividing by 3, we're finding a third of, which at year 5 and 6 level, they can start seeing that it's multiplying by a third. If you modeled this and then said, now show me what you've got multiplying and dividing by 3, for example, and let them go, and they're not allowed to just write out 3 times tables or whatever. They have to actually show how can you prove that that's the answer to that? How can you actually prove it to me? Because I don't believe you. And I mean, they never need an algorithm, because even if I was, say, dividing 482 by 3, because I understand multiplicative place value and powers of 10, I can say, well, I know that 48's a multiple of 3, so 480 is a multiple of 3 as well. That kind of thing. And that's the really deep thinking that we want these kids to be doing, rather than just reaching for a calculator or doing a quick algorithm. It's like, you already know the answer. 48 divided by 3 times 10 is going to be the answer to 480 divided by 3. It's that kind of thinking that we really want them to be starting to do. Every time they say something, their next sentence has to be, I know this because. And then they have to explain how they know that, how they know that, how they know that. Moving away from show your work to show your thinking. And if it is something that you just know, like you just know what 48 divided by 3 is, it's like, yeah, that's fine. You didn't have to work that out. You just knew that automatically. That's fine. Okay, now 480, go. What would you do? And this is where you see if they say things like, oh, well, I would add a 0. Because that's showing you don't have deep understanding that it's actually the digit that's moving, or you actually multiplied by 10. And that's where that multiplicative place value down at year 3 level starts. Again, you might have some kids that get that, so you'll have this up as a level, but other kids will still be working on this. So by having this up as an anchor chart, and you've explicitly taught it in front of them, even though they're going off and investigating this, they're still exposed. And also they might be sitting next to a child who's investigating highest common factor while they're still investigating multiplying and dividing by 2 or 4 or 3 or whatever. They're still sharing with one another what each of them is doing. Up until year 3, kindergarten, year 1 and year 2, kids are thinking additively, which means that, for example, addition and subtraction are obviously additive because we're joining groups or taking a group away. Place value is additive in year 1 and 2 because we're just adding the values of the digits. So we're just adding the 1s and the 10s and the hundreds and getting the number. From year 3 onwards, they still stay additive, but we bring in multiplicative thinking. I would make sure that the kids were thinking multiplicatively about concepts that are multiplicative. So the multiplicative concepts are multiplication and division, place value becomes multiplicative, and fractions. So the way that place value becomes multiplicative, and this starts in year 3 with whole numbers, and then in year 4 goes into tenths and hundredths, and then year 5 goes into thousands, and then year 6 numbers of any size, is we're starting with 1, and to get the value of the column on the left, we're multiplying by 10. And to get the value of the column on the right, we're dividing by 10. So at year 3 level, it's whole numbers, it's 1 times 10 is 10, divided by 10 is 1. But thinking multiplicatively means we're not seeing that when we multiply 1 by 10, we're getting 10 ones. We're getting a number that is 10 times bigger than 1. And if we've got 10 and we divide it by 10, we get a number that is 10 times smaller. And then in year 4, when we have 1 and we divide it by 10, the number that is 10 times smaller, we start talking about it's a tenth as big, which is why, or it's a tenth as much, which is why it's a tenth. And then they extend that understanding to know that 1 is a tenth of 10, and 10 is a tenth of 100, and so on and so on. Additive place value, because you've got standard and non-standard to thousands. This is where you differentiate down to teen numbers, 20s numbers, 2-digit numbers, and so on. Because even if you're doing a teen number, when you're demonstrating that 15 is 1 10 and 5 ones, and 15 is 15 ones, that's exactly the same concept as 1.5 is 1 1 and 5 tenths and 15 tenths. The kids will start to see that relationship. And then if you're doing a 20s number, it's the same as 2 point. If you're doing a 2-digit number that's 86, it's the same as 8.6. You can put up anchor charts in your classroom so that you've got one level up. You see some kids are getting it, leave that one up for the kids that still need to investigate that, and they have to demonstrate understanding of that level before they go on to the next level. You're going to record the model on a sheet of A4 paper, and that's going to stay on the wall. Then when you go on to tenths, you're going to record that on an A4 sheet of paper, that's going to stay on the wall. So you won't be holding your top kids back. Your top kids will get to thousandths and numbers of any size quite quickly, but they will have the understanding of how it related with whole numbers, then how it got onto tens, hundreds, thousandths, and that kind of thing. How do you get kids to see decimals? You link it with metric measurement. So here you can see that when we're doing all of this work on decimals, at the same time we're investigating metric measurement. Metric measurement starts in year 3, and it's multiplicative too. 1500 years ago, the Hindus invented our place value system, and they only invented it with whole numbers. Then 500 years ago, European and Arabic mathematicians decided to extend it to decimals, so they divided by 10 to get a tenth and a hundredth and so on. 300 years ago, French mathematicians invented the metric system, and they based it on place value. So they started with a metre, they divided it by 10 to make it 10 times shorter, and they got a decimetre. And deci means tenth in Latin. Then they divided it by 10 to make it 10 times shorter, and they got a hundredth of a metre, and centi means hundredth in Latin. And then they divided that by 10 to make it 10 times shorter, and they got a thousandth of a metre, which is a millimetre. So in year 3, we teach metric length at the same time as whole number place value. Then in year 4, we teach metric length at the same time as tenths and hundredths. And year 4 kids already know that the next one's going to be thousandths, because milli means thousandth. Then in year 5, we extend that to 10 metres, 100 metres, 1,000 metres. So 10 metres is a decametre, 100 metres is a hectometre, and 1,000 metres is a kilometre. And then when you do area, a square hectometre we call that a hectare. Anything multiplicative, we want to make sure that they've got that deep understanding at the year 3 and 4 level, which is when it was introduced. And now year 5 and 6, now we're combining all of those multiplicative concepts. Fractions are multiplicative because we're not just saying that 2/4 is a half. That's additive because we're adding the 2/4 together to make the half. We're saying that a quarter is half of a half, and an eighth is half of a quarter, and a quarter of a half. And again, they do that by making the fractions out of paper. Even kindergarten kids can fold a piece of paper in half. It's more focusing on the language and the understanding that it's now half as long as it was before. And my eighth is half as long as my quarter, and my eighth is a quarter as long as my half. And then when they start multiplying fractions, so a half times a half equals a quarter, or a quarter times a half equals an eighth, that kind of thing, they've got that basics of, yeah, I folded a piece of paper into eighths and I did divide my half into quarters. So it's not just trying to learn stuff by rote, it's actually this really, really deep understanding of it.